Okay, what, instead of just a review of this topic, this topic, this topic, and this topic, I want to review in terms of some problems, some applications, some of the reasons why we study this course. Last time we sort of did that. We took a revenue model where we know 2 points on a graph of the number sold versus the selling price. In other words, we started with the idea that if we sell for $50, we're going to sell 200. If we sell for $80, we're only going to sell 7. Those aren't the numbers, but you know, that kind of thing. Okay. And we then realized that the revenue, okay, well, then we assumed there is a straight line. It gave us the number sold versus the revenue. And we found the equation of that straight line. Using y equals mx plus b, we had to find m and b. Have a couple of ways to do that. One way is with simultaneous equations. We have 2 points in the graph, so we have a y and an x to plug in for y equals mx plus b for the first point, and we have for the second point. That gives us 2 equations, and then we can solve that equation by using matrices. We can solve it using just straightforward elimination. We can solve it using substitution. Solve it approximately using graphing. We can solve it in a number of ways. But since we've been talking about matrices, we chose to use matrix methods. Okay. Now that reviews a whole lot. That reviews linear functions. Okay. And then when we multiply the price by the number sold, we're going to multiply x by the linear function. It's going to give us a quadratic function that has a graph. And we graph that quadratic function, find its vertex, find its axis of symmetry, we find its zeros, find its y-intercept, and we get that graph. You have to be able to do that with a quadratic equation. So in that one example, you see a lot of things that you need to make sure you know how to do. Okay, a lot of things you need to review. If you don't already know, you already know a lot, but it's been a while. I'm not going to remember it forever. Okay, so you got to get it back into your working memory so you can do well on the exam next week. And I really hope to do real well. Okay, I know you can. You have the time to review. Okay, okay, so anyhow, this is another instance, again, another quadratic function. Okay. So let's just ask a couple of questions to this function. What's the height at t equals 3 and at t equals 10? Now, this is a review. We want to get as much done as possible. So unlike most classes where I ask you to get your hands on it and do it, I'm not going to give you much time to do that. Okay, so just write out what you think the expression would be for the height. How would you get the height at t equals 3? How would you get the height at t equals 10? Or could just tell me, because there aren't that many of you here today. Okay. Okay, so everybody seems to understand. Now, the compact way to write this would be h of 3 and h of 10. Okay. And h of 3, if you plug it in, you're going to get what? Negative 45 plus 90 plus 45. You're going to get 65. And 10, you're going to have negative 500 plus 300 is negative 200. And negative 200 and add 20. going to get negative 180. Okay. Now this means the negative 180 means you might have thrown this thing up in the air. Okay. There better be a pretty good drop off out there to get to negative 180. Maybe you're standing on a hill 20 feet high next to a cliff 1,000 feet high, and it works. Anyhow, those are your heights. If I did my arithmetic correctly, and I think I did, you can evaluate it. Point is, you know how to get that. Okay, well, that's good. Okay. When is the height 0? Okay, so first response I got was, oh, you plug in T equals 0. I think I've heard that. No, that's the height is 0. T is not 0. Okay. If you plug in T equals 0, you get information. Plug in T equals 0, you can see where this is at time 0. And that would just give you 20. Okay, we'll see that when we graph it. We do some other stuff. Now, when is the height 0? Well, that happens when h of t equals 0. Okay. And I was starting, one person said, I tell you, you can use the quadratic formula and do all that. Well, yeah, you do after you write out the equation. Okay. Nobody wanted to tell me this. So you want to make sure you understand this. H of t equals 0, so negative 5 t squared plus 30t plus 20 equals 0. So the t equals negative 30 plus or minus the square root. I'm doing shortcuts. You know how to plug into the quadratic formula, so I'm not going to demonstrate that. You're going to have 900, and then you're going to have 400. So it'd be square root of 1300 over negative 10. And you get two answers. Okay. Now the square root of 1300 is between, well, 1300 is between 900 and 1600. Okay. And actually turns out that 35 squared is 1250, I think. So that's going to be pretty close to 35. And that gives me something ridiculous. Trying to figure this out. It's not working somehow. Oh yeah, you do the minus because you divide by the minus stuff. And you get about 6.5 or something like negative 0.5. Now, actually, I can tell pretty much it ought to be like negative 0.6. So I'll actually use that information. I don't say where I got that information. Okay. So I'm going to say it's 6.6, maybe even probably not close to 6.7. Okay. So anyhow, you write the equation, you write out the solution, and you get two solutions. Okay. Now, the only solution you're interested in is the one that's greater than 0, which is 6.6. There's a meaning to the negative 0.6, and I'd love to go over this meaning. Okay. Because it involves even to me going to mathematics meetings as a lunatic. In claiming that has physical meaning and some metaphysical. You don't know. I think it's kind of funny. But I don't actually do that. Okay, so anyhow, you get t equals 6.6. Does that make sense? If the height is 65 and t equals 3, and then gets to negative 180 by the time t equals 10, does it sort of make sense that somewhere between 3 and 10 it's going to be Zero. Um, okay. And it's speeding up, so yeah, there's all kinds of things you can do in analyzing this motion, but we're not doing physics, we're just doing the math, so there you have it. Okay. So we've got some information about this thing. So if we do a graph, we've got several points that we put on the graph. We could put the point 365. We better have a lot of negative numbers here. Okay, so let's just say that here's t is 3. And then out here is t equals 10. And let's just say that t equals, or the y equals 65 here. So we have this point. And y equals 0, of course, when the height is 0, and that occurs at about 6.6 seconds. So for 0, and then the height is negative 180 when t equals 10. So let's see, t equals 3. Well, here's t equals 10. If this is 65, then 180 would be about 3 times that. So y equals negative 180 occurs here. So we've got 3 points on this graph. Okay. We've actually got 4 points because if t equals 0, y equals 20. So somehow this thing is going up, reaches the t, and comes down. And that's the graph. The graph has to be a parabola because this function is quadratic. Okay. What if we didn't know what the function was? The question I'm going to ask now is, I'm going to pick the point 0, 20. Y is 20. X equals 0. 365. And negative 180. Forget what the function I gave you really is. Just say functions quadratic. So suppose that somebody else was observing this function. Okay, somebody had a camera and they said, okay, when it started, it was 20 feet high. After 3 seconds, it was 65 feet high. And after 10 seconds, it was 180 feet below where it started. Okay. Okay, it's quadratic. Okay, now the person with the camera knows that this is going to be a quadratic function or something close to. Okay, get some air resistance in there and it makes not quite quadratic, but that's physics. Don't worry about it. We'll assume it's quadratic. Okay, so y y equals at squared plus bt plus c. Okay, now. Y equals 20, t equals 0, so we get 20 equals a times 0 squared plus b times 0 plus c. Y equals 65 if t equals 3. So we get 65 equals a times 3 squared plus b times 3 plus c. Y equals negative 180 if t equals 10. So we get negative 180 equals a times 10 squared plus b times 10 plus c. That's three simultaneous equations in three unknowns. Now I can three linear equations and three unknowns. I'm going to write the equations. Zero A plus zero B plus C equals 20. The second equation, well, A is multiplied by 3 squared. I'm going to bring my A, B, and C over on the left. I'm going to have 9A plus 3B plus C equals 65. And 100A plus 10B plus C equals negative 180. Now I'm going to rewrite those equations a little bigger, but we see that these equations come from this. All we've done is we said, okay, somebody observes these 3 points. They don't know what our function was, but they observe these 3 points. Do they conclude the same function that we know? Okay. We assume a quadratic function because that's the way projectiles work. Okay, ignore error systems. So we take these 3 points. Each point gives you an equation, because each point gives you a t and a y. So we get that, and now we have the equation for the system. Okay. Now, what do we do to solve this system? Actually, several ways we can solve. In the first place, we know that C is 20 because we got 0A plus 0B. So we can change C to 20 in the next 2 equations. Then we just have 2 equations in 2 unknowns. I'm going to pretend we don't think to do that. I'm just going to write out the augmented matrix. And you know what? Just for illustrative purposes, I'm going to write these equations in reverse order because they can be in any order. They're the same equations. So I'm going to say equations are 100A plus 10B plus C equals negative 180, and 9A plus 3B plus C equals 65, and 0A plus 0B plus C equals negative 180. All right. Now I'm going to write this as an augmented matrix. And that's right. This one should have been 20, not 180. 180. Okay, so this is 20. Okay, do you understand what I'm doing? So all I'm doing is taking this situation from the real world and first analyzing it if we know what the function is. But then assume somebody's watching this, observes the height at 3 times, that gives them 3 points on a graph, and then tries to figure out what the function would be. Okay, in order to do that, you assume this form. You plug in the y and t value for each point. We get 3 equations, and now we solve those 3 equations. Okay. Okay, well, we should get something close to a equals -5, b equals 30, c equals 20. Now, I'm not going to go through the details. It's easy enough to solve this. Okay, we'll start just by multiplying the first equation by 9 in the first line, first row by 9, second row by -100. And then just proceed from there. It's actually a pretty easy system to solve. Okay. It'll be a little harder to solve because what you've got is the last row is already solved for you. You can see it's 20. If we used these 3 points, it would give us something that's different and the system would be a simple. It wouldn't be a bad exercise just to write that out if you have time. Now, let's just say that all you had was 3 points. You do this, you get that equation, okay? So now what's the maximum height? What's the maximum height and when does it occur? Find that out with graph the function. Not using t equals 3 and t equals 10, although that gives us a pretty good idea. Y-intercept is 20. Reviewing. Y-intercept occurs when t equals 0. It's 0 when t approximately equals 6.6. Zero when y equals 0. Now, I'll also say, or negative 0.6, because the negative 0.6 will help us with the graph. Remember, if we know the function, we just solve this and we get those two solutions. Axis of symmetry is at negative b over 2a, which is negative 30, 2 times negative 5 equals 3. Now that's a little bit bizarre because it's square 1300 is not exactly 35. By 1300, correct? Well, I'm questioning that. We're going to go on. Okay. Axis symmetry is, oh, never mind. It's okay. Okay, that axis symmetry is at t equals 3 in this case. All right. From that information, we can easily graph the quadratic. It's going to look a lot like the graph hourly grid. Now we can see that, in fact, t equals 3 is the vertex. Now, I didn't even intend to make vertex at that time. I just picked a number. That's okay. Got t equals 10 out here, but that doesn't really, well, t equals 6.6 and t equals negative 0.6 are the x-intercepts. So now we know that our graph is nice parabola with these intercepts. And it's perfectly plausible that it's negative 180. Right. So again, given the function, of course, we can get the graph, but just given 3 points, we can get the quadratic function using simultaneous equations and matrix reduction. And then we can figure out what the graph is. Now there's a lot of content here. Among others, you have to understand, you have to be able to graph a given quadratic function. And this is the method for doing this. Not going to define the method very specifically. This is a review day, and we only have a little over an hour left. No, not even an hour left. Okay, about 40 minutes left, a little over 40 minutes left to do other stuff. So, but we've talked about linear functions, talked about quadratic functions. Okay. So let's shift gear and talk about exponential functions. Pause for just a second. Okay. So again, a paradigm example, an exponential function is going to embody quite a bit of what we need to know. T is a quantity that varies with T. Okay, now P could have two connotations if you want to use a connotation. P could be a population. Okay. You got a big old pond and you put a couple of fish in it, and the population of fish then starts growing. Okay, if you got a fertile pond and fertile fish. Okay, so P varies with time. Population varies with time. Another, the principle of an investment. Put a chunk of money into an account at 5% interest. Okay, then that account grows at 5% every year. Okay, so P varies with time. So P could be population, P could be principal, be money. Okay. Every time T increases by 1, P increases by 5%. And let's not say 5%. I like to use 10% because it's easy to do 10%. Okay. Suppose P starts at 1,000. Then when T equals 1, time would have increased by 1. Population goes to 1,100. T equals 2. P is going to increase by 10%. It was 1,100. Starting at 1,100, increased by 10%. It goes from 1,200 to 10. Okay. Now you note that 1,100 is 1.10 times 1,000. Why is that? Because when you add 10%, you're adding 0.1 of whatever you had to what you have. So the 1 times 1,000 is what you started with. The 0.10 times 1,000 is what you added. So you need to understand that. Now we've talked about that when we introduced exponential functions. But Also 1,210 plus 1.10 times 1,100, but 1,100 is 1.10 times 1,000. So it's 1.10 times 1.10 times 1,000, which is 1.10 squared times 1,000. That does take a lot of imagination to understand that, yeah, we started with 1,000. Here we did 1.10 times that. Here we did 1.10 times that, which means that we did 1.10 twice to the 1,000. So we did 1.10 squared times 1,000. Okay. P of t turns out to be 1.10 to the t times 1,000. So now we have this function. P of t equals 1,000 times 1.10 to the t. Find p with t equals 10. Find when p equals 5,000. We find how long it takes to double p. This causes us to review what we know about exponential functions and exponential equations. And these are things you need to know how to do when you get to the test. So let's see. Tell me. Okay, now I got some very good answers. Okay, when I close this. Okay. Population is, or principal or whatever it is P of 0 equals 1,000 times 1.10. It's not 0, it's 10. Okay, times 1.10 to the 10th. Okay, well, you plug that into your calculator. You're going to get something maybe maybe around 2,600, give or take 100 or so, but I'm not going to think hard and try to make a good estimate there. Okay, so that's easy. When does P equal 5,000? Well, when function equals 5,000, your function is 1,000 times 1.10 to the t. That's equal to 5,000. You divide by 1,000, you get 1.10. The t equals 5. Okay. So that t equals log base 1.10 of 5. Now, I'm not going to belabor how you change exponential to logarithmic. We did a lot of that, and you know where to find that if you don't remember it. Just be sure you remember it when you take the test. Okay? And you're going to find, I'll bet, that that's equal to about maybe 17, big question mark. Okay. Pretty good at estimating things. I can refine that estimate, but don't expect that to be all that accurate, okay? Now, I'm going to do this in the general case because you're doing really well. I'm going to write this equation. P of T plus T sub dov, that's DOUB, and that just means your doubling time. That's what you're trying to find. Equals 2P of T. We can solve this. T dov. Okay. First, we write out the equation, and I guess I'll write it here because there are a few steps. So we'll come on over here, and we write and didn't leave myself reading to write the equation. What am I going to do about that? Write it down here, but I won't have room to solve it. Well, I want to keep it close down here. I couldn't find that out. So, okay. So, T of T plus T dov equals 1,000 times 1.10 to the T plus T dov. And that's going to be 1,000 times 1.10 to the T. We can divide both sides by 1,000 and make this a lot shorter. We get 1.10 to the T plus T dov equals, and it over here it should have been 2 times 1,000, okay? Equals 2. We thought 2 times 1.10 to the T. Now that equation, I'll bring up here. Write it again, 1.10 to the T plus T dov equals 2 times 1.10 to the T. Now, at this stage, it's not completely obvious how you solve the equation. But I'm going to solve it to use so that I can illustrate a little bit about rules of techniques, okay? There are 2 ways to solve this. One way would be to divide both sides by 1.10 to the T. All right? That's probably not something obvious. The other that might be a little more obvious is that 1.10 to the T plus T dov is all kinds of stuff. Right, this is wrong. Okay. Okay. A to the B plus C equals A to the B times A to the C. This is a rule of exponents people tend to lose track of. Now, if I said A squared times A cubed, you probably say, okay, that's A to the fifth. But when you have A to the fifth, you don't necessarily think, well, I could write that as A squared times A cubed. Okay? And you don't necessarily think when I see 1.10 to the T plus T dub, that would be 1.10 to the T times 1.10 to the T dub. Okay? In any case, that equals 2 times 1.10 to the T. Now, what does this suggest? I got 1.10 to the T here, 1.10 to the T here. I divide them out, and I just get 1.10 to the T dub equals 2. And T, the variable T, is completely out of the equation. So T dub doesn't depend on T. So T dub equals what? Log base 1.10 of 2 that you know how to solve. Okay, now we can relate this back to one of the first constructions I had you do. You construct the toolkit exponential function. And I'm not reviewing that. That's something I expect everybody knows how to do. All the stuff that's on the midterm can appear on the final, okay? So go back to the midterm review, whatever. But anyhow, I can construct the graph of the toolkit exponential function. Now, you know, from the construction of this graph, that each of these lines, starting from the lowest construction line, the next construction line is twice as high as that one, the next is twice as high as that, the next is twice as high as that, and the next is twice as high as that. So it should be obvious from the construction if you move over one, move twice as high relative to the lower edge, twice as far from the lower edge, if I wanted to say that really rigorously. Okay, but this is twice as high as 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 this, if this is constructed correctly. Because of course, starting from the upper, we go twice as close to the lower edge, then twice as close again, twice as close again, twice as close again. We continue doing that forever. We never get there. But we stop at this point because it gets really hard to squeeze those lines in. Okay. And this is enough to give us the basic shape of an exponential. So in this case, every time we move over a unit, we move twice as high. Our y value doubles. Every time our x value changes by this. So whatever the dimensions of this box are, this box could be, let's say this box is 1,000 by 800. Okay. then this is 250. I'm writing those 250 is really small. But if this is 1,000, this is 250. And this isn't y equals 2 to the t. This is a transformation of y equals 2 to the t. And you got a vertical stretch of 800, horizontal compression by a factor of 250. Okay. And I can write out the equation for the function, but I'm not going to ask you to do that. Just understand that every exponential function is transformation of this one. Okay. And has the same properties. And the property here is the doubling time is constant. That's obvious from our construction, and that's going to be the same no matter what the size of the rectangle is. Okay. So a very important characteristic. Okay, so just another example of where we have what might be a practical problem. Okay. If you think that there are things going on in the world, conflicts settle down, and artificial intelligence, robust, increased productivity, we could easily get to a point where we have growth of wealth or growth of pay beating inflation by 10%. Okay. If that's the case, then we see how many years it's going to take before $1,000 investment is really worth $5,000 in today's money. Okay. Turns out about 17 years. Now, 17 years doesn't seem like long to me. It probably seems like a little while to you. Okay. I mean, 17 years, I probably won't be here. I think of what happened 17 years ago. And it seems pretty recent. Okay. Wasn't that last week? Well, okay. So that's just another thing that we need to understand. And on the final, I'm going to pose some problems of this nature. Okay. I won't make them too much different than what you see here and what you've seen in some of the others. Okay. Now another little plug. Let's go back to this, wherever it is. Again, using can you construct? Okay, how would you construct a fundamental triangle? On the interval 6, 7. Okay, so I asked the question. Nobody really could tell me. But somebody said, well, it's something about the equation of a straight line, f y equals mx plus b. Okay, well, yeah. If you got 2 points on a straight line, you can draw a fundamental triangle, find the slope. the fundamental triangle. So here you got 2 points. Here's your fundamental triangle. You got the rise. And you got the run. And slope. Equals rise divided by the run. And then what's the rise mean? What's the run mean? You know what the rise means, what the run means, you figure out what the slope means. You got an applied calculus course in your future? No? This is the last math course you got to take? Maybe statistics? Okay. It's all right, still good for your soul. Okay, now, you have fundamental triangle on the interval 6, 7, and it's part of this course, you gotta know. You know, you might, you know, you've obviously got the ability to do pre-calculus. So, I mean, like that. So let's use another color. Okay, now fundamental triangle on the interval 6, 7. Well, let's just say, I'm exaggerating a little bit, but let's say it. Let's say t equals 6 on this line. And t equals 7 on this line. Okay. Then the graph points for t equals 6, well, the graph point is here, right? And the graph point, this point is here. And our fundamental triangle goes from one point to the other. We go vertically, then horizontally, or we go horizontally, then vertically. Come out the same either way. Right here is our fundamental triangle. And here's our hypotenuse. And our hypotenuse stays real close to this curve. Now, the hypotenuse is a straight line, and the curve isn't a straight line, so they're not identical. But if you got a pencil that writes it all thick, the curve is close enough to being straight right here that you pretty much nail it. Now, question then is, they don't sell chocolate right. So I'm going to bring this picture out here so I can draw it a little bigger and label it. So first of all, we've got to try. Something like this. We go over here, go down here. We need the coordinates at this point and the coordinates at this point. Okay. Now, can you tell me, without having to write a lot of stuff out, can you just tell me what we would do to calculate the coordinates of these 2 points? Okay, I'm really proud. I've managed to confuse you so much you don't remember what you knew when we started. Okay, and that's of course always my goal. Seriously, yeah. If t equals 6, how do we determine the coordinates of this point? Well, we've got this function down here, h of t equals -5t squared plus 30t plus 20. And what I asked you a while ago, how are you going to find the height of t equals 3? You say, well, you just plug it in for t. Now, if you want to find h, your y value, your h of t for t equals 6, what are you going to do? You're going to plug in 6. And if you plug in 6, and you know that, I kept trying to drag it out of you, but you know, you can only keep that going so long in a day when we've only got 8 minutes left. Okay. So you plug in 6, that's going to give you 36, and you give you -180. Oh, 6 is just so wonderful here, because this gives you plus 180, you get 20. Okay. So this point is I need that space, 65 is coming over here. Okay, I need 6, got it. 6, 20. This point is 7, what? How are you gonna find it? You're gonna plug 7 in down here, you know, okay? And you plug in 7, numbers are a little more difficult, but you square 7, you get 49, 5 times 49 is 243. Right? Yep. 245, sorry. And that's 150, so you got a deficit of 95. So it's negative 75, I think. So when you're asked to find a rate of change on an interval, which almost certainly is going to be asked, okay? Rate of change is just the slope of your fundamental triangle. Okay? Now there are other definitions, you know, including y2 minus y1 over x2 minus x1, but they aren't geometric. They don't show you much. They just get the right answer. Now, if you know those formulas and then pull that together with trying to understand what's really going on, you know, the formulas can be valuable, but people don't usually use them that way. Okay, so anyhow, we have this. So what's the rise? What's the run? Well, run is 7 minus 6, which is 1. Rise is negative 75 minus 20, which is negative 95. Okay. So the slope equals rise over run. And remember, back when I was doing this, I said, you want to write all of this out, and nobody does. So nobody remembers a thing about it. When you're learning something, write it out. You don't learn as well if you don't write it out. That's true of 99% of the population. There's recent research that even confirms that more than anybody with common sense would have known in the first place. Okay. So slope is rise over run, which is negative 95. I put a box around that. Now, review the way I said to do it originally. What's this telling you? Well, the value of the function is how high you are in meters. And the time to be in seconds. So you have meters in seconds. Your rise is negative 95 meters. Your run is 1 second. And your result seems to be a little bit high. Hang on. Negative 25 t, which would be negative 150 plus 37 plus 20. Not sure I believe these numbers, but anyhow, that's how it's calculated. There's something wrong. So I think there might be some kind of mistake in, you know, my mental arithmetic or something. Yeah, I think my negative 975 is probably about, let's see, negative. Yeah. Yeah, we've only got 3 minutes left. I'm going to correct it. But negative 75 might not be right. Okay. Now, I haven't been able to review everything, but I've reviewed some of the really high spots. Okay. Now, we haven't talked about the main range, all the stuff in chapter 1. You should be able to make good sense out of all of that by reviewing, because now you see how it works. Okay, now you see how it behaved. For example, the domain of this function would probably start at t equals 0. This is where you threw that projectile up in the air, okay? This part of the curve wouldn't be relevant to anything. So your domain would be from 0 to whenever it hits, whatever stops it down here, okay? So stuff like that, common sense. And the range would be from the height you have down here up to the maximum height here. You know, those things have meaning. Transformations. I assume you can do the transformations, okay? And make sure you know how to do the transformations. Make sure you know how to construct basic graphs, transform them, transform functions, okay? And you might have to review that. And then you get into polynomials and rational functions. And we spent plenty of time learning how to graph these things. You're going to want to review that because you're almost certain to see something. Okay. Now, if you have questions on any of that, you have a really hard time reviewing it, email me, come by. I'll have some office hours next week. Usually be here between 12 and 2, at least Monday through Wednesday. And maybe earlier than 12, maybe later than 2. Okay. Might be 12 to 3 on the first 3 days. But between 12 and 2 is pretty good time, and I'll post those hours. I'll email when I get the schedule in. Okay. So this wasn't a comprehensive review. We tried to hit high spots, but to show you how things work together. And you did well. Okay. So if you review everything, I'm hopeful that you're going to do real well in the exam. Okay.